Hello students, in this module we are going to discuss about numerical based on Kirchhoff's law. It is my humble request dear students to please try to understand how do I apply KVL in my given equations. So this is the best example to understand the question of KVL. Now the question says, in a given circuit, find the current flowing through 100 ohm resistance and the terminal potential difference across E2. So I'm supposed to find two things. I'm supposed to find the current that is flowing across 100 ohm resistance, which is in the center branch of your circuit, and I'm supposed to find the terminal potential difference across E2. Now what is this? The terminal potential difference is because of the internal resistance of the cell that is given to us as 1 ohm. So we need to understand that 1 ohm is the internal resistance of the cell, due to which there will be some potential drop, and due to that I'm supposed to find that potential drop. So what is the potential difference across E2? So let's try to understand dear students. Since there are internal resistances, I can easily simplify my circuit as 1 ohm in series with 1.5 volts as well as 1 ohm in series with 3 volts. Now, since there are two different batteries or two different EMF, two different current will flow. So let's try to find the current I1 from 3 volts and 1.5 volts having current I2. So current flows from positive terminal to negative terminal of the battery. So I1 will flow from positive, I2 will also flow from positive, and at point P it's a junction or a node. So both the currents are incoming. So the current that is flowing in 100 ohm resistance is nothing but I1 plus I2. So this is my first thing that I'm supposed to find. Secondly, dear students, again at point C, incoming currents will again be splitted into outgoing currents. Now, what I'm supposed to find, can I not say I'm supposed to find I1 plus I2 and I'm supposed to find the potential drop at E2. So after analyzing and deciding the direction of currents, I will try to apply dear students KVL. Please understand the concept. How do I apply KVL? KVL, let's try to apply in my first loop. So what is my first loop? I am taking my first loop to be A, B, C, D and A. That means this is my first loop. How do I apply KVL? 4 simple steps. Direction of tracing equal to direction of current, the product is minus IR. Direction of tracing opposite to the direction of current, it is plus IR. EMF minus 2 positive is the direction of tracing, hence it is plus E. EMF from plus to minus, it is minus E. Now let's apply. Do I have anything at branch AB? No dear students, I don't have anything. I'm not going to apply KVL here. Do I have it branch BC? Yes dear students, I have 100 ohm resistance and the current is I1 plus I2. So the equation will be minus 100 I1 plus I2. Do I have anything in CD dear students? No, I don't have anything at branch CD. But do I have anything at branch DA? Yes, I have 3 things. One is a 3 volts potential from minus to plus, so it is taken as positive. 1 ohm resistance is in the direction of tracing, so it is minus I1, and 99 ohm resistance in the direction of tracing, so it can be taken as minus 99 I1. That's it. We have applied the KVL. I hope dear students you got this. How do I apply KVL? Now I'm just simplifying. I'm just opening the bracket of minus 100 I1 can be written as minus 100 I1 minus 100 I2, and minus I1 minus 99 I1 can be written as minus 100 I1. When I further simplify dear students, what I get is minus 200 I1 minus 100 I2 should be equal to minus 3, and when I take 100 common, what I'm left with me is 2 I1 plus I2 equal to 0.03. Similarly dear students, I'll try to apply KVL in my second loop, that is B, C, F, E, B. So when I apply KVL, what about BC? Yes, 100 ohms in the direction of tracing, so minus 100 I1 plus I2. Is I have anything in CF? No, I don't have. Do I have anything in FE? Yes, I have. So what I'll do? Minus I2 into 1 ohm plus 1.5 minus 99 into I2 should be equal to 0, because I don't have anything in branch BE. Yes dear students, should be equal to 0. So when I again simplify, what I'll get is minus 100 I1 minus 100 I2 plus 1.5 minus 100 I2 should be equal to 0. Again clubbing the equations, and again can I take out 100 common? So when I take out 100 common, what remains with me is I1 plus 2I2 should be equal to 0.015. So I have two equations, dear students, and after these two equations, what I want? I1 plus I2 as one of my finding factors. So I'll add these two equations. So when I add these two equations, what I get is 3I1 plus 3I2 should be equal to 0.045. So when I take 3 common from LHS and RHS, I can say that I1 plus I2 should be equal to 0.015. That is my first answer, which can also be written as 15 milliamp. Now on solving equation 1 and equation 3, I2 comes out to be 0, and thus I1 can be written as 15 milliampere. Now what about the potential difference? Yes, dear students, I want to find the terminal potential difference. So terminal potential difference is given as E2 minus the drop in the cell, that is I2 R2. But I2 is 0, dear students, so I can easily say V2 is equal to E2, which can be written as 1.5 volts. So that's it for this module. Thank you.